This equation is a little bit tougher because we have two different bases of e's. One is e to the 2x, the other is e to the x, and then we have a term without a base of e at all. What makes this problem weird is that it's basically a quadratic equation under disguise. We can think of it as the quadratic 2x squared plus 5x minus 3, because I know that e to the x times e to the x, we would add the exponents and I'd get e to the 2x. And so this is kind of like an x squared, taking our middle term and multiplying it by itself. So we could think of factoring this equation just like a quadratic equation. So this quadratic is going to factor into 2x and x for sure to get our 2x squared. And then we need to figure out where to place the 3 and the 1 to get this 3 here. I know I want to eventually add to 5x's, so I'm going to place the 3 right here so it gets multiplied by the 2x. So then I'll place a 1 in the other location. I want a positive 5x, so that means that I want this 3 times 2x to give us a positive 6x, which will make this 1 negative. Again, this is equal to 0. So my two solutions will end up being negative 3 and a positive 1/2. What we need to remember is that we're not solving just a quadratic. We're solving an exponential equation that looks like a quadratic. So we could factor this to e to the x minus 1, e to the x plus 3. So basically, instead of x's, we're replacing them with e to the x. So that would mean that 2 times e to the x minus 1 would need to equal 0, and e to the x plus 3 would need to equal 0. I can rewrite this as e to the x equals negative 3, and I can rewrite this as e to the x equals a positive 1/2. From here, we need to find what these exponents need to be, keeping in mind that base e has a special logarithm, the natural log, that finds exponents. So x will equal the natural log of 1/2, and x will equal the natural log of negative 3. We'll go ahead and type this into our calculator, natural log of 0.5, and that will give us negative 0.6931. Now hopefully you notice right here, we know that we cannot plug negative numbers into logarithms. You could try it in your calculator and you're going to end up getting an error. So this would not give us an answer. Our only answer is the first one.